I'm going to solve with you example 3. The distance between major crack can be modeled as an exponential distribution with mean of 10 miles. Okay, so we know that on average the cracks appear in 10 miles of distance. So what is the probability that there are no major crack in 10-mile stretch of highway? So to answer that, we will denote our x as a distance between the major cracks. So it's not always the case that your x is a time between the event. Sometimes your x can be the distance between the failure or the distance between the major cracks. So in this case, again, we are using an exponential random variable. Now, if we know that the mean is equal to 10 miles, so your lambda parameter will be 1/10, which is 0.1 cracks per mile. Now, what is the probability that there are no major crack in a 10-mile stretch? It means you are saying that what is the probability that the cracks appear after 10 miles. So to compute that probability, what we are going to say, we are going to integrate from 10 to infinity, or we can use this formula, probability x greater than k, it is equal to e minus lambda k. So your lambda is 1/10, your k is here as a 10. So we get as our answer as e minus 1. Okay, that is just directly applying the formula for probability of x greater than k. Now, question 2, when you say that what is the probability that the first major crack or the first failure, as we can say, appear between 12 and 18 miles. So in that case, you are saying that what is the probability that x is between 12 and 18. So to compute that, you can integrate from 12 to 18. You use a function for exponential, or you can use this formula directly. Probability x is between k1 and k2, and the answer is e minus lambda k1 minus e minus lambda k2. So here, if you multiply lambda with k1, which is 12, you get minus 1.2. And if you multiply lambda with the k2, you get minus 1.8. So that's the difference between that, and you can use a calculator to get the exact answer. Now the last part for this question, given that there are no cracks in the first mile, so you already know that in the first mile, no cracks appear. What is the probability that no major crack in the next 15 miles? So what is special in exponential distribution? There is one property called memoryless property. So it means that no matter what happened before, we have to consider what will happen next. So when we say that this, you can express it as like this: probability of x greater than 15 plus 5, given that x is already greater than 5. So to compute that, we can use what we are saying, what will happen in the next 15 miles. So what is the probability that no major cracks appear in the next 15 miles? So that is called memoryless property. And to compute that, as I told you, probability x greater than k, we can use directly the formula for that, and we will get the answer. That's all for example 3.